Hello, and welcome to our tutorial on the world scripting system. In this video, we'll cover the core concepts of scripting that enable you to create truly interactive experiences. After this video, you'll understand the scripting foundations for creating interactions like shooting weapons, flying spaceships, hitting targets, shrinking or enlarging a player's avatar, and more. My name's Andy, and I'm a game developer in Unit 2 games here at Meta. And this video will introduce the scripting system that powers worlds and helps you add life to your creations. This content is designed for both new creators and those experienced creators transitioning from the legacy code block scripting system. This knowledge will help you understand how scripts create interactivity in worlds, learn the fundamental building blocks of the world scripting system, interpret scripts from tutorials or templates, and begin creating your own interactive elements. This video covers an overview of the TypeScript APIs. An API is essentially Application Programming Interface. It's the functions that we can call between worlds and our scripts, and core concepts that form the foundation of world scripting. A demonstration of how to build a simple interactive script from scratch, as well as best practices and troubleshooting techniques. It's worth bearing in mind this video assumes some familiarity with TypeScript. So we're not going to cover TypeScript basics in this video. Instead, what we're going to do is cover how Worlds implements it for interactive experiences. The community-made Creator Manual GitHub repository provides additional resources for those who want to deepen their understanding of the world systems. Before diving into specific code, it's important to understand the fundamental building blocks of the world scripting system. All interactivity in Worlds is built using TypeScript, also shortened to TS, which allows you to access the Horizon Core API, the collection of pre-made functions, classes, and constructs that let you build interactive experiences, and other libraries that extend beyond the functionalities of Core. As mentioned earlier, this video assumes you have some knowledge of TypeScript. However, if you're familiar with other programming languages, learning TypeScript should feel fairly familiar. There are loads of excellent resources already available for learning TypeScript, including online courses and tutorials, which we're not going to cover here. Let's start with two core concepts of the world scripting system: APIs and script types. The world scripting system includes several specialized APIs for different purposes. The core API is the fundamental building blocks for creating interactivity. There's the UI API, which is specialized functions for creating and managing user interfaces. The Camera API, these are tools for manipulating the player's point of view. There's a NavMesh API, functions for character navigation and pathfinding, and many more that you can find in the API reference documentation. In today's example, we'll focus primarily on the core API, but understanding that these different API categories exist will be really important as you build more complex experiences. The world scripting system also includes several important types and classes. The world is the container for your entire experience, and it includes all of the entities and groups and scripts and everything else. An entity is an object in your world, and a component is a reusable piece of functionality which can be attached to an entity. The player construct contains attributes and managing methods for players in your world. Assets are resources like sounds, textures, and 3D models, and there's more constructs beyond. However, today we're going to focus mostly on components, as these are the foundation for most interactive functionality in worlds. A component in Worlds is a self-contained script that defines behavior for an entity. The basic structure of a component includes prop types, or props definition, which define the properties the component can accept in the world builder. There's also the pre-start function, which is the method that runs before the component fully initializes. And then there's the start method, which runs after the component has fully initialized. Beyond that, there's optional new or overwritten methods that are called from within or outside the component class. It's important to understand when to use a component versus a module. Components are attached to specific entities, and they help define their behavior, while modules are better for global functionality that isn't tied to a specific object. For example, you might want to use a module for common maths operations and then make that available to all of the components. Components can be created from the scripting panel and attached to an entity by selecting it in the attached scripts drop-down of an entity's properties. In the code of the component, you can define props definition. These are variables that can be adjusted through the properties panel of an entity without needing to change the code, and these make your components a lot more flexible and reusable. Let's look at the component lifecycle. So there's a part of this where the component is prepared. The component is created when the world simulation is initiated. So that's essentially where the pre-start method runs, and the scripting system becomes aware of the component. Shortly after that, the start method runs, and this is where the simulation is already running. The start method executes, and the component is officially active at this point. During the course of the component being available in the world, other functions and other methods will be called, and then when the entity is destroyed that this component is attached to, the component will go through a teardown, which essentially is where the component is disposed and no longer needed. The API reference documentation contains details on all available functions and properties for creating interactive experiences. Now let's put theory into practice by creating a simple interactive script from scratch. Let's make a balloon that pops when a player grabs it, and after 3 seconds, we'll reset that balloon so that we can pop it again. So in this example, we're going to cover entity typecasting, force releasing grabbable entities, modifying the visibility of an entity, playing effects like sounds and particles, using the set timeout to delay code execution. So we're going to start in a new world with nothing else in it. In the asset library at the bottom here, I'm going to make sure that I'm in public assets, and I'm going to look for balloon by typing it in the search box here. There's a range of colors as well as groups of balloon. I'm just going to use a happy red balloon here. And let's make sure that we've selected the move gizmo, or press W on the keyboard and move it into a position that makes sense for us. I'm going to put it right in front of my spawn point here. On top of this, we also will need a confetti particle effect. So I'll just type confetti in the asset library search panel, and up pops the confetti particle effects. I'll drag that into the world. That probably needs to be a smaller scale and positioned exactly where the balloon is. There we go. And I also want a pop sound, so I'll just type pop in here and see if, oh yeah, there we go. So we got SFX, and we've got a range of pops to choose from. So I'm going to just choose the first one, drag that into the world. It doesn't really matter the scale for the audio gizmo, but I'm going to make it smaller so that it's just easier to see what else is going on in the world. And I'm going to drag it into the same location as the balloon. There we go. All right, so now we've got a balloon mesh, we've got a confetti particle effects, and we've got a pop sound in the world. The next thing we need is a script to manage the behavior of the balloon. So the way we create a script is up here with the scripts drop-down menu. I'm going to select the scripts menu, and then I'm going to click create new script. I could also click this little create new script plus icon here if I wanted to. That does the same thing. I'm going to call this balloon pop. Okay, and then I hit enter, and you can see the script has now appeared in the scripting panel. Let's go ahead and attach that script to the balloon. So I'll make sure that I've got my balloon selected, and then I'm going to go to attach script. So on the properties panel on the right hand side, I'm going to scroll to the bottom, and I'm going to choose on the drop down next to attach script. I'm going to select that drop down and choose the balloon pop script. Whilst I'm over here on the properties panel, let's make sure the balloon is grabbable. So to do that, I'm going to, on the motion property, I'm going to select that drop down and click interactive. Grabbable is already selected, but just in case it's not, make sure that grabbable is selected for your interaction. We can actually test that before creating our script by going into the world and grabbing the balloon. And now I have the balloon grabbed. Cool, so that bit's working. Let's now go in to edit our script, which we've attached to our balloon. So I'm going to go into the script drop-down menu, click on the 3 dots, and then click on Open in External Editor. And this will open it in VS Code. So the way we're going to do this is we actually want to attach an event listener to our balloon. So we basically want to listen out for whenever a player grabs that balloon. And the moment that we want to attach that is actually before the balloon even exists. So it's during the pre-start function. So I'm going to type pre-start. If you just type pre, let me do that again. If you just type pre, it will actually pop up with like some suggestions using the IntelliSense there. So I can then select from those suggestions the pre-start method. Okay, and then the next thing we want to do is this.connect code block event. And this is essentially saying, let's listen out for an event that happens. Open brackets. I'm going to put in the entity into the first parameter. This.entity refers to the entity that the component is attached to. So in this case, it's our balloon mesh that we just set to be grabbable. So this.connect code block event, open brackets, this.entity, comma. The next thing we need is the event that we want to listen out for. So hz.codeBlockEvents dot on grab start. This is referencing a specific thing. In fact, if you want to, you can control click on grab start and you can see what it's referencing here. And then finally, before the end of the brackets, we want a callback function, which is the functionality that's going to be called when the player grabs the balloon. And so we can do open brackets. There's a couple of things that automatically get sent to this callback function. The first is right hand, and that's a true if the player grabbed it with their right hand, or a false if they grabbed it with their left hand. It's always true for web and mobile players, so it's worth bearing that in mind. It's only really impacts VR players. And the other thing we want, the other parameter we want in our callback function is player. After the bracket for the callback function, but before the end bracket for the code block event, we're going to do equals, greater than symbol, open parenthesis, and hit enter. And this is where we can write the code that will run, that will execute for our callback. We want to make the balloon invisible, and we want to turn off, we want to force the player to release the balloon as well. So let's do those things. This.entity.visible.set, open brackets, false. And then this.entity, and now we need to, not all entities are grabbable, so the grabbable functionality is actually hidden and only accessible to grabbable entities. So we need to convert this.entity into a grabbable entity. The way we do that is we cast it, so we do as, open brackets, hz.grabbableEntity. That will then unlock all of the grabbable functionality for that entity. Force release, and this is a function, so let's just do open close brackets at the end. So we set the balloon to be invisible, and we've set the player to let go of the balloon. We also need to play our sound effect and play our particle effects. And in order to do that, we're going to need a reference to those two things. So in the props definition, I'm just going to hit enter, and I'm going to add sfx, which will contain a reference for our sound effects. The type is hz.proptypes.entity, and a comma at the end. And then I'm actually going to press Shift Home to copy that, Control C, paste it underneath, and let's change sfx to VFX so that we have a reference to both our sound effect and our VFX. Okay, so now that I've added those two props to the props definitions, I can save this script, go back to the world builder, and then if I select the balloon, which had the script, the component attached to it, and scroll down the bottom of the properties panel, I can see that there's SFX and VFX. These two properties are now available for me to set in the world builder. And I can just click and hold on the particle effects and drag that into VFX property. Or I can select the little circle icon here and use this drop down to select the other one. So I'm going to use this to select the sound effects. So you can use either drag and hold and release over the property, or you can select the drop down there. So now these properties contain references to the sound effects and the particle effects in the world. We can do some fun stuff with that. So let's go back to our script, and we're continuing in our code block event handler. So before the end parenthesis of this function, let's add another couple of lines of code. So the first one is we need to check if this.props.sfx. Let's just check that that is not undefined, because it could well possibly have not been set. And if it is not undefined, it means it is a thing. We'll play the sound effects. This.props.sfx. Again, we're going to need to cast this to unlock or to open the audio gizmo functionality. So this.props.sfx.as hz.audio gizmo, and then we can call outside the bracket dot play open close brackets semicolon. So this will play the sound effect, and we actually need the same, pretty much the same thing for our VFX. So I'm going to copy that and paste it just below. Change SFX to VFX. Change audio gizmo to particle gizmo, and that's all we need there. Now to finish off our function, let's make it so that we can do it again and again. So we want to reset our balloon to the state it was before after about 3 seconds or 3000 milliseconds. And the way we can do this is this.async.setTimeout, and then we can put a callback in this function for the first parameter, and we'll need a comma and 3000 after the parenthesis but before the end bracket. And that essentially says call this functionality 3000 milliseconds after in the future. So here I'm going to reset our balloon to how it was before. This.entity.visible is now true. So we're going to make it visible again. We'll turn back on collision to this.entity.collidable.set true. And I've just realized I didn't actually set collidable to false up here. So let's copy and paste that up here, change that to false. So at the start of our function here, we're going to make it invisible and no longer collidable. At the start of our reset function here, we're going to make it collidable and visible again. And I think that's everything we need. Okay, so I'm going to press Control S to save it and return to the world editor. And it's worth keeping an eye on the scripts menu at the top of the screen, because it's going to have a little yellow dot, which shows that a script is compiling. And then it's going to have a little blue dot, which means that the script has finished compiling and it's starting to run. All right, so we've connected our properties. We've attached our script. We've got a particle effect and a sound effect. Let's make sure our particles and our sounds are all hooked up correctly. So if I select our particle effect here, I need to change our prefab name to confetti burst. We don't want it to play on start, because that'd be weird. You like load into the world and it starts confettiing everywhere. We want it to wait until we've grabbed the balloon. So we're going to turn off play on start. If you want to, you can also preview what it's going to look like here. Let's just make sure that everything's correct with our sound. That looks all good to me. Cool, that's it. Let's enter preview mode and see the results. So I'm going to press enter preview mode. I'm going to grab the balloon. It pops, disappears, there's confetti, and then it's back. And we can keep testing this. Yay, confetti. All right, now that you understand the core concepts and have seen a practical example, let's look at a helpful debugging technique that will help you troubleshoot your scripts. When you're writing your script, you want to use the console to see what's happening at runtime. So some logging levels you can use to categorize the different messages that you might want to send to the console include a log for outputting just general information during script execution. You can also use warn to highlight yourself potential issues that are not critical errors. and then errors that will indicate critical problems that need immediate attention. Try practicing using console.log by calling it in the grab event of the balloon script. So let's go into our balloon script again. And within our code block event, so after the first parenthesis here, I'm going to just add console.log open brackets, and then let's put some words in here. So we're going to put them in quotes, which is a string, and we're going to say, you grabbed the balloon, and exclamation mark, semicolon at the end, and Control S. Now, if I clear my console by clicking the clear button, if I run the world, preview the world, and then grab the balloon, I should be able to see that a message appears in the console log at the bottom. If you can't see your console log, then you might want to click this up arrow here and make sure that it's selected at the bottom. Another thing you can do is add a console gizmo to the world. So in the build menu, I'm going to click on gizmos. I'm just going to search in gizmos for console and drag a debug console into the world. And you can choose which ways this gizmo can be seen in the properties panel. So over here in the properties, I can change the visibility from edit mode only to edit and preview mode. It's looking kind of small, so I'm going to press R on the keyboard and then click and drag to increase the size of this. I'll press W and move it up so that I can see it easily, and then I'll preview the world. If I grab a balloon now, I should be able to see on the console log, it says you grabbed the balloon. So this is really handy not only when you're previewing the world in the desktop editor, but also the debug console is really useful when you're testing the world in VR. Having it visible in Publish can be helpful when you're trying to debug any issues you have after you've published your world. So you would set the visibility to in published world. After you watch this video, check out the description for additional resources and links to the documentation we've mentioned here to deepen your understanding. Watch the other videos in this tutorial series to build on these fundamentals and take your projects to the next level. Of course, scripting in worlds is just the beginning. As you move forward, remember that every complex interaction starts with these basic building blocks. The principles demonstrated in our balloon example apply to many other interactive elements. Regular practice is the main key to developing your scripting skills. We encourage you to take the concepts learned today and apply them to your own unique interactive elements. Start with simple modifications to what you've seen, then gradually build towards more complex interactions as your confidence grows. Thanks, and I'll see you in Worlds.